Hello. Today we're going to be doing 6.4, which is talking about geometric sequences. So sequence is just a set of numbers here, and a lot of these times these numbers will have patterns. So looking at this 1, 4, 7, 10, each time here I can get to the next number by taking and adding 3. So for the next three numbers it would be 13, 16, and 19 when I add 3 each time. For my pattern here, I'm going to say I'm adding 3. Versus the next one is once again a sequence, it's a set of numbers, and it does follow a pattern 1, 3, 9, 27. Each time here, instead of adding 3, we're multiplying by 3. So if we do 27 times 3 is 81. 81 times 3 is 243. 243 times 3 is 729. So our pattern here is we're going to be multiplying by 3. Now with sequences, we're going to have a bunch of different things to talk about with the different notation. So for this one, you see 2, 4, 8, 16. So every time here things are doubling, you can look at your sequence and figure that out. You can figure out how to extend it by just doing multiply by 2. But we're going to have different things here. We're going to have an n and an a sub n. Now the n is just talking about whatever term number you're on. So if I were to say n equals 4, that is talking about the fourth term. It's telling you to go 1, 2, 3, 4, and so I know to look at the 16. Versus a sub n, this is actually the value of the nth term. So I can say, what is a sub 4? And what is that is saying is it's saying go to the fourth term, because that's what n is, but tell me what that equals. So the value of the fourth term is 16. So I'm actually looking at what it equals. So a sub 1 here is referring to when n equals 1, what is my value? So what is my first term? The first term in the sequence is 2. A sub 2 means find the value when n equals 2, and that is going to be the second term, which is 4. The third term in the sequence is 8. The fourth term is 16. And the fifth one we could extend out and multiply by 2 to find 32. So we're going to need to be able to write things either with an n or a sub n accordingly. Now taking a look at the different warm-ups here, the first one we said was we were adding 3 each time. And so that actually comes from last semester. That's going to be an arithmetic sequence. So with arithmetic sequences, you are going to add or subtract the same number each time. That number is known as D, aka your common difference. And what you did with your arithmetic sequences was you took and you wrote them in slope-intercept form, but you used a sub n instead of y equals. So today we're going to be focusing on the next pattern, which we said was multiplying by 3. And so what's happening here is this is called the geometric sequences. So geometric sequences are when you multiply by a common, or by, we'll call it the same number each time. Now you notice I only said the word multiply. You also do think of it as dividing, but just like before with our exponential stuff, we're going to always try to write it as multiplication. So if, for instance, it said divide by 3, we would say times 1/3. So R is going to be that common ratio. That is going to be whatever number you multiply by to get to the next number. It's the number you multiply by to get to the next number. You might have to go hunting sometimes for that common ratio. So the rule for geometric sequences, those are going to follow exponential rules versus linear rules because geometric is multiplying by the same number. So for your rule, it's going to be a sub n equals whatever your first term, so a sub 1, remember this right here, this stands for your first term is, and then you're going to multiply it by r, which stands for your ratio, to the n minus 1. So for our example up above, we're going to write a sub n equals our first term is 1. Our common ratio here is what we multiply by to get to the next term. So that's going to be 3 to the n minus 1. So the n up as your exponent is kind of like having your x in your equation, and your a sub n is kind of like your y in your equations. This is your rule for that pattern above. So let's take a look at this and try a couple of examples here. So for A through F, pause the video, look at the sequences, and you decide if they're arithmetic, meaning adding, geometric, meaning multiplying, or neither, meaning no pattern. So after you've gone through and tried it, take a look at A here. We're multiplying, makes it geometric. B, you are adding 4 each time, which makes that arithmetic. C didn't really follow a consistent pattern, so that one was neither. D, you are subtracting 7, making that arithmetic. And E, you had to hunt for it a little bit, but your common ratio here is times 2/3. If you ever get stuck on these ones, you can always take one number and then divide by the previous number, and that should give you your common ratio. And once you find it's 2/3, you can then take and test it by later taking a number and multiplying by 2/3 and seeing if it gets you to the next one. So this one actually ends up working. It is geometric then. And our last one, you're taking two numbers and adding them to get to the next number. Even though that's a pattern, it's not specifically adding the same number each time or multiplying, so it's neither. So let's take a look at this sequence. We want to identify each term and then write the rule. So looking at this, my first term is when n equals 1. My value of my first term is 8. The value of my second term is 12. A sub 3 then would be 18, and A sub 4 would be 27. Now looking at this, there is going to be a common ratio here. There is going to be a pattern. This is one where we can go ahead and test it by doing 12 divided by 8. And when we reduce that, we get 3/2 or 1.5. And let's test another one. Let's do 40.5 divided by 27. And when we reduce those, we do get 3/2 or 1.5. So that 3/2 then is our common ratio. So to write the rule, it was a sub n equals a sub 1 times r to the n minus 1. And we have to plug in two things. We have to plug in our first term, which in this case is 8. And our common ratio is 3/2 to the n minus 1. And you can always test your formula by taking one of your values here. So if you go ahead and let's say we wanted to find a sub 4, if you plug in 8 times 3/2 to the 4 minus 1, this then should give you the same answer that you set up there. So it should give you 27 when you type that into your calculator. And if it does, that means you're doing it right. So let's write the rule, and then let's go ahead and find a couple of things after that. So here we have an equation. It's going to be a sub n equals our first term times the rate to the n minus 1. So we need to find our first term. It's 3072. Our rate we can find by dividing. So we're going to do 768 divided by 3072. When we do that, we get 1/4. And let's test it. 48 times 1/4 gives us the 12. The ratio there should be That's our rule. To find a sub 7, we're going to go ahead and equation, so 3072 times 1 4. We're going to plug 7 in for n. We're doing 7 minus 1. Now in your calculator, honestly, the way I would do this to avoid any mishaps would be to just figure out what 7 minus 1 is, and that's 6. And so you're going to type all of this in your calculator and hit enter. So 3072 times 1/4 to the 6th power. And then when you do that, a sub 7 should be 3/4 or 0.75. So then to find the 9th term, we're looking for a sub 9. It's 3072 times 1/4 to the 9 minus 1. Again, we're plugging in 9 for n. So in your calculator, you would do 3072 times 1/4 to the 8th. When you do that, that gives you the 9th value of 0.046875. Or if you wrote it as a fraction, it would be 3/64. Any of those would be okay with me. And for our very last one here, we are not given necessarily the first term. We want to write the rule. So for our rule, we need to know the first term and we need to know the common ratio. Now we can find the common ratio here. To get from 100 to 10 and from 10 to 1, you're dividing by 10, which we're going to write as a fraction. So we're going to write it as multiplying by 1/10. So that gives us our ratio. We just need to find our first term. So we divided some number by 10 to get 100. So we're going to work backwards. We're going to multiply by 10 to figure out what came right before it, and that would be 1,000. And we're going to work backwards one more time to figure out that our first term, when we multiply by 10, should be 10,000. And so we want to write the explicit rule here. This would be our formula. So thank you very much for listening. I hope this helped.